Dear all of my students in the network class, which is CMP 270, let's go today with the chapter 2, which is the physical layer. In this chapter, we will look at the lowest layer in our protocol model. The protocol model, which is related to the ISO standard 7-layer protocol reference model, or the TCP/IP reference model. Then in this chapter we will look again at the lowest layer in the protocol model, which is the physical layer. Define the electrical, timing and other interference by which bits are sent as signal over the channel. It means that when we talk about the transmission over the channel, we can talk with each other about what's meant by bit, what's meant by byte, what's meant by octet, what's meant by bit rate, what's meant by baud rate, what's meant by information rate, what's meant by error rate, what's meant by code, what's meant by code length, what's meant by code capacity, what's meant by serial transmission, what's meant by parallel transmission. Then all of these, the parameters, when you go with the transmission over the physical layer, then we have to talk about the bit rate, say for example, which is the throughput, which is related to the number of bits transmitted per second. When you talk about error rate, which is the rate of errors over the transmission media, we will talk later about the details of the transmission media. Then we talk about the number of bits, the ratio between the number of bits received with error over the total number of bits transmitted. Whatever, in the physical layer is the foundation on which the network is built. The properties of different kinds of physical channel determine the performance, which is throughput, latency, and error rate. So it's a good place to start our journey here for the network into the network land. Then we will cover 3 kinds of transmission media, which is what we call guided transmission media. Here it is, which is related to the cable transmission media. We will talk in details for the 2-wire line, coaxial cable, fiber optics as an example. And then we will go with the unguided transmission media, which is radio transmission, wireless transmission, or radio frequency transmission. Let's go with starting with the physical layer here, which is the foundation on which other layer build. The properties of wire, fiber, wireless limit what the network can do. Mean that when we said that the properties of the wire, fiber, wireless limit what the network can do, it means that the bandwidth for each one. Each transmission media here have a bandwidth for transmission, whatever it's kbit per second, megabit per second, gigabit per second, depend on each transmission media. We will come to that point later. And also the parameter which affect the network is the error rate. How is the error rate for each transmission media? Then if you look at the physical layer here, it's a lower level layer on the TCP/IP network, which is the physical layer, link layer, network layer, what we call here IP layer, transport layer here, which is TCP layer, and application layer. The key problem is to send digital bits using only analog signal. This is called the modulation. We will talk later, or in this chapter we have part for the modulation technique as an amplitude shift key, frequency shift key, phase shift key, and different type of modulation. If you go here with each other for the guided transmission media. Guided transmission media, for this case here, the purpose of the physical layer is to transmit bits from one machine to another. It means that various physical media can be used for the actual transmission. Each one has its own niche in terms of bandwidth, which is the rate of transmission, delay, which we call end-to-end delay or variable delay, the cost for the type of transmission media, which is differ, we will see the comparison later, and the ease of installation and maintenance. Then media are regularly grouped into guided transmission media, which is related to the copper, wire, and fiber optics transmission media, and unguided transmission media. We will talk later about the radio transmission. It means that for the guided transmission media here, media have different properties, hence in performance, looks like we have the media as a twisted pair, coaxial cable, and the fiber optics. Let's start here with the wire as a twisted pair. When we talk about twisted pair, which is the early transmission media, one of the oldest and still most common transmission media is the twisted pair. Very common, used in local area network, telephone line, twist reduce the radiated signal or the interference. It means that why it is twisted, to reduce the interference through the transmission distance. When we talk about the link terminology over the transmission media, we talk about the mode of operation over the transmission media. Then we have what we call full duplex link, half duplex link, and simplex link. Now we talk about the two-wire line. We talk about the simplex link. Only one fixed direction at all time, not common. Means simplex, it's one-way communication. It's a transmitter and the receiver only. Looks like the radio transmission, TV transmission. We have a TV transmission station. We have radio transmission station. Then we have a transmitting the one-way transmission only. Half duplex here, which is related to in both direction. You have a transmit and receive at both direction, but it's only at one at a time, but not at the same time. It means that both direction you can transmit it, you can receive, but not at the same time. Full duplex here, it means that you have a transmit and receive at the same time. Then, when you talk about the two-wire line as twisted pair, from the structure point of view, we have what we call shielded twisted pair, STP, unshielded twisted pair, UTP, and foiled twisted pair. Each one have a different characteristic. Each one have a different bandwidth. Each one have a rate of transmission. As an example, when we talk about unshielded twisted pair, we have a different category. We have Cat 5, Cat 6, Cat 7. All of them have a different rate of transmission. Let's go with the second guided transmission media, which coaxial cable. Also common, better shielding and more bandwidth for longer distance and higher rate than twisted pair. Compared by twisted pair, it's used for more long distance and more bandwidth. And if we go with the coaxial cable here, we will see that the coaxial cable can be thin coaxial cable, can be thick coaxial cable. Then each one have a different bandwidth and characteristic. Let's go with the third one, which is the fiber cables or fiber transmission, which is coming here as common for high rate and long distance. Fiber cable is the most common long distance communication right now, with very high bandwidth as a gigabit per second and very low error rate, which coming 10 to the minus 11 to 10 to the minus 13. It's mean that it's long distance internet service provider link, fiber to the home, and the light carried on very long thin strand of glass. Then you have here the source of the light and the photo detector here, and this is the fiber transmitter. If we go with the fiber here, then we have what we call single mode fiber and multi-mode fiber. For the single mode fiber, this is used for long distance communication with the core so narrow, which is 10 micrometer, and the multi-mode fiber, which is other type of fiber, which is the 50 micrometer core